this video, we're going to quickly derive the welfare implications for a firm, profit maximizing firm of a change in the prices. We start with defining profits as equal to price times the quantity as a function of x minus x times W, which are the input prices, minus our fixed costs. Note that throughout most of this video, we're going to be assuming that X and Q are vectors, so that P and W are also vectors, and so this is all vector notation. The profit maximizing firm would take the first derivative with respect to X in order to find the profit maximizing quantity of inputs, which would give rise to a profit maximizing quantity of outputs, and giving us the first order condition PQ of X is equal to W. In principle, we can invert this function to obtain a input demand function X hat, which is also a function of the input and output prices, and a supply function Q hat, which is also a function of the input and output prices. The profit function is a very specific function. It's not just equal to profit, but rather profit at the optimal choices. So you'll see that pi hat, a function of input and output prices, is the maximum profits that can be obtained by maximizing over our input choices. In this case, we assume that X, that is all of the inputs, are greater than or equal to 0. The quasi-rent function is very similar. The only difference is that the fixed costs are suppressed, that is eliminated from the quasi-rent function. This will make our lives a little bit easier. Writing out the quasi-rent function in a little bit more detail, we can see that you can either write it as P times Q, which is also a function of X hat, or in the second expression, it's going to be P times Q hat minus W times X hat. If we take the derivative of the quasi-rent function with respect to the price, we obtain Q hat plus, using the chain rule, PQX minus W times the input function with respect to price as well. In the same way, we can take the derivative with respect to the input price, giving us RW, which is simply minus X hat of PW minus PQX minus W, the same expression we had above, this time with the input demand function with respect to the input price. However, since we know that this is solved at the optimum where PQ of X minus W is equal to 0, the terms PQ of X minus W in the two expressions above are equal to 0, which leaves us that the derivative of the quasi-rent function with respect to the price is simply equal to the supply function, and the derivative of the quasi-rent function with respect to the input price is minus the input demand function. Using the definition of a definite integral, a change in the quasi-rent can then be simply defined as the definite integral between a lower price P0 and an upper price P1, taking the derivative with respect to the first derivative of the quasi-rent function as a function of P, which is just equal to an area underneath supply function. Notice that this integral is over prices, not quantities. So rather than the area vertically under the demand curve, it's sort of the area horizontally under the demand curve. So as we integrate from P0 to P1, we sort of move up, filling in the area under the supply curve, leading to the area there, which is our typical measure of what you'd recognize as producer surplus. In the same way, we can also integrate under, I put under in quotes, the demand curve for the input, and that's defined by the integral from the lower price W0 to the higher price W1, giving us an equivalent measure of a change in quasi-rents. Now we need to define two different particular prices. They call them shutdown prices in Just, Hueth, and Schmitz. They're frequently known as choke prices, and these are the prices that would lead the plant to stop producing. So P1 upper bar 0 is equal to the highest price such that the quantity produced, or the quantity demanded is equal to, the quantity of input demanded is equal to 0. Similarly, the shutdown price for inputs is the lowest price such that the quantity of inputs demanded is equal to 0. Now, clearly, if the prices are really, really low, they're going to demand a lot. So we want to find, and if they're really, really high, they'll demand nothing. So we want to find among those prices that are so high that they shut down, we want to choose the lowest such price. That's what the shutdown price is. In this line, we simply substitute the shutdown prices into the vectors of input and output prices to show that the input demands are equal to 0 at those prices. And since the input demands are equal to 0 at those prices, the quasi-rents are also equal to 0 at those prices. So using the definition of, using the integral presentation of the change in quasi-rents that we showed above, we're now going to use a definite integral over from the shutdown price P upper bar 1, 1 to any particular price P1, 1, and that's simply equal to the expression on the right hand side, the second term of which is equal to 0. So we have now shown that since the derivative of the quasi-rent function with respect to the output price is equal to the supply function, we've shown that the quasi-rents associated with a particular input price can be found by integrating under, and I use the under in the horizontal sense, it's the supply function. And in the same way, we can integrate under the input demand function from the shutdown price W1 upper bar to any particular price to obtain the quasi-rents associated with a particular price. So as long as there exists a shutdown prices for both input and output prices, we can use those areas underneath the demand and supply curve to obtain a measure of the quasi-rent, and either one will suffice.